So yeah, we'll get started. So in this webinar, we're going to be talking about how we can supercharge our conversational AI with RAG agents and memory. Just as a sort of point of interest or housekeeping, you'll see within the webinar that we have like a chat. So in there, you can chat. You can set on your two, you can set to everyone and talk between yourselves. But for questions, we do ask that you add your questions into you should see like a little Q&A box, and then we'll kind of go through those towards the end of the webinar. So I'll jump straight into it. Go on to the next slide. Okay, so myself and Bilge will be talking you through everything today. Obviously, I'm from Pinecone, as you can see, and Bilge from DeepSet, which is the company behind Haystack. Next slide. So when we're talking, this is one example of where we might want to use something called RAG, and I'll explain what RAG is very soon for those that are new to it. But what you can see here is LLMs, like this thing in Haystack called agents. That's something we'll be talking about, but it's more of a recent thing. And here I'm asking GPT-4, right? The GPT-4 is, it's like the most powerful LLM out there, right? But it can't answer this question because agents are it doesn't know about agents. It hasn't learned about them because that sort of knowledge is more recent, right? And LLMs, they kind of get a little bit stuck in time based on, when they're trained. So in this question, in this answer, it talks about other things, but it doesn't talk about agents. And there's nothing useful in there for us. So next slide, please. So when we see that sort of issue, it's not like this sort of lack of connection to the outside world or this sort of frozen nature of LLMs is not the only issue that we have with them, right? It's not just about the fact that they don't have knowledge on like up-to-date information. There's also many other cases where they can be kind of problematic. So a couple of examples here is like internal data. So internal data is where you have like one very common use case is organizational data, right? So at least the last time I worked in a big company, I remember using the sort of internal search tool for documents, and it was just so like incredibly bad. Like it was using like it's based purely on like a keyword search, and it's very difficult to find what you need to find. And that has been a very common use case for a ton of organizations like across the world. This is pretty typical. Essentially, adding this sort of internal data as something that your LLM has access to. So you can chat with an LLM like you would ChatGPT, but it also has access to that internal data. So you can actually ask questions about those internal documents, or just at least ask a question and see which document would be able to answer that question. So that's a really good use case for internal data. Other examples might be like your personal notes, emails and messages, that sort of thing. Maybe you'd also like to kind of chat with those as well. Niche domains is another thing. So LLMs have very good general knowledge, but when it comes to more specific niche knowledge, they don't necessarily perform quite as well, right? So yeah, that can be, particularly if you're working within a particular space with not so much documentation out there on the web, that can be a problem. And we see this a lot with different languages. So if you try and build a chatbot that's going to help you with Maldivian or Nivea regulatory documents, there's a good chance that you can't just use like ChatGPT off the shelf and it will work. you need to give it some input. There's also freshness. So that's the idea of like up-to-date documentation. Like if you're an e-commerce company, you have your stock list. It needs to be up to date for any chatbot to give your customers like up-to-date information. So that's another important task that LLMs by themselves are not really up to. And then just hallucinations. So LLMs have this tendency to try and please us a lot. Like they want to keep us happy. So even if they don't know the answer to something, there's a pretty good chance they're actually going to pretend they do know the answer to it and just make something up. That seems really convincing as well, which obviously isn't actually that good for us because, we end up believing something that is just completely made up. So yeah, these are some of the biggest issues with LLMs. And if we can move on to the next slide, we see that that issue is, it just comes from how LLMs are built, right? You can think of them as kind of learning. They have a training data set, and from that training data set, they kind of learn to understand the world, right? But the world as it appears within that training data set, right? So at that point, after you've trained it, it's just kind of frozen, right? It doesn't learn anything new, even when you're telling it things, right? An LLM is stateless. So you tell it something, if you make another call to it without like conversational memory or anything like that, it will have already forgotten what you told it, right? So they're frozen in time. They don't have any sort of like connection to the external world or a subset of the external world or anything like that. So yeah, that's our problem. If we move on to next slide, we see the solution. Actually, two solutions. So fine-tuning is basically training your model a little more. And then we also have retrieval augmented generation, which is a big part of what we're going to be talking about today. So if we go on to the next slide, we will talk about fine-tuning. So fine-tuning is really good if you want to like modify your chatbot behavior. It gives us, so if we train it on a new data set, it gives us like pretty accurate knowledge. And to be honest, sometimes like really surprisingly accurate knowledge of data. But the fact that we have to train it, like fine tune it, means that we can only do that every so often. And it's kind of expensive to do it a lot. So it's not that useful if your data is updating often. And in some domains, you kind of want to be very sure that you're being accurate. And fine-tuning alone doesn't necessarily give you that. And that is because, we have this X here, trust in results. The main problem is that we don't know where that information is coming from. An LLM it's a black box, right? It's going to say things, generate text. We don't necessarily know where that text is coming from. So that can be problematic. And as I said, data updates quickly, problematic as well. Next slide. So RAG, on the other hand, different pros and cons. So RAG is great for fast changing knowledge that needs to be managed. You can think of RAG as like, and we'll talk more about it, but it's kind of like a database that your LLM has access to. So you can kind of manage the LLM's knowledge, essentially. It's because we know where the information is coming from. You can add citations to your outputs, which really helps in just user trust. We see that with like Bing. They include citations. Learning and storing facts about users. So if you have a chat, this is a really good solution for storing those chats or storing modified or generated versions of like facts that the LLM is using for later use. On the other hand, like chatbot behavior, I mean, maybe you could try and do like modified chatbot behavior with RAG, but I wouldn't necessarily recommend it. I'd go with fine tuning. So yeah, that's pros and cons of RAG. And obviously, if you can need both, I always just recommend you use both. Like you're going to get better results when you make the use or make the most of both RAG and also fine tuning. Okay, Next slide. So yeah, I've spoken about RAG and fine tuning, but I haven't really explained what RAG is exactly. So it's kind of what you see here. That little box in the middle would kind of be like the RAG component. So we essentially get information from the world, whatever information that may be. Maybe it's our like internal company documents, our emails, or maybe it's our stock list for our e-commerce company, right? We put them into that little box, and then we connect that little box up to our LLM. If we move on to the next slide. So what we're doing when we use RAG is we're swapping this sort of frozen in time LLM. So the knowledge of the LLM, which we call the parametric knowledge, is that only contains the knowledge that it learned from the training data set. We're kind of swapping this for the next slide, which is this. So we're basically adding like a long-term memory component to the LLM. And when you're using vector database for that long-term memory component, we have the added benefit of being able to kind of organize that or manage that as we would a normal database. So we can add and delete and update stuff. And yeah, you can think of it as adding, deleting, and updating the knowledge that the LLM has inside it. So yeah, next slide. So the question I'd say one of the problems that I see happen a lot is when people are like, okay, I want to add this external information to my LLM, but maybe they've either come across RAG or they're like not entirely sure what RAG is or something along those lines. The first problem I see very often is like this question, right? How do I actually put that into my LLM? Yeah, we can go on to the next slide. And the answer that a lot of people come up with initially is going to be like, okay, could we put everything into the context window? Right? I'm sure you've seen that that with recent LLMs like Claude, the context window is increasing, and that's like everyone gets really excited. Like for me, that is like I haven't found it that useful. And the reason for that is kind of what you see on the screen right now. The more documents you put into your, or the more text you put into your context window of an LLM, the less accurate it gets, right? So, we can have 100,000 tokens context window, and that's great. It's like, I don't know, it's many, I think maybe hundreds of pages of PDFs. But in reality, we're just kind of like throwing it all in there, costing ourselves a lot of money with using so many tokens. And the LLM is actually just forgetting most of it. We move on to the next slide. And this is another visual from the same research that found this. What you basically see is in that context window, your LLM remembers the first part of your context window, forgets the middle, and then remembers the end. And it forgets so much in the middle that if your LLM knew a piece of information before you put all of those documents into it, and then you pass that information in through a document, and you put it kind of like in the middle there, it's actually less likely to get the answer correct than if you just didn't give it the document in the first place. So yeah, you need to be really careful with this. And I always, the way I think about this is like, if I gave you 10 words to remember, I didn't tell you what we're doing this for. I was like, okay, just look at these 10 words. And then I took them away and I was like, okay, tell me which words you remember. People always remember what was the first couple of words and the last few words. Very few people remember the middle words. And it's exactly the same with LLMs. They just forget what is in the middle. And to make things worse as well, what you'll also see is when you feed a load of things into an LLM, it's less likely to follow like instructions that you've given it, or other things. So you need to be careful with how much you're feeding into that. So yeah, next slide. So this is, going back to RAG, we need to think of like a better way of doing that. So the idea behind RAG is that you're, rather than just throwing everything into your LLM, you want to just be selective and feed only the most relevant items into your LLM. So the way that we do that is we use semantic search. So the thought process behind this is, okay, an LLM works in natural language. You pass natural language into it, it generates natural language. It understands natural language, right? That's kind of like the like operating language for it. So with semantic search, we keep everything within natural language. So also the search that, or say we have a query into our LLM that's in natural language, we can do the search with that natural language and we can actually get relevant results. Because the way that we do this semantic search focuses on meaning, right? And you'll see that in the next slide. So the idea behind this semantic search is, like I said, searching on meaning. So when you look at these like first three phrases here, we have the word bank, right? A traditional search using keywords would just see bank and it'd be like, okay, they're all the same. Whereas with semantic search, you'd be looking at the context, right? You're looking at what is around the word bank. And based on that, it's going to understand that this has a different meaning, right? Each one of these words, although it's the same word, it has different context, it has different meaning. Then on the bottom, we have kind of the opposite scenario, right? So there's no keywords, there's no words shared between these two sentences, other than like to and the, right? They're not relevant words when we do searches. Everything else is a different word, yet they kind of have the same meaning when we read them as like people, right? So we want these two terms to kind of come together within our search. So next slide. Now, the way that we do this is we take what's called a transformer model. So transformer model, well, you all know them actually, whether you call them transformers or not. Like an LLM is like a really big transformer. For those of you that have been doing some sort of embeddings, you probably have used text embedding order 002 from OpenAI, or you've used the OpenAI embeddings class in LangChain. So you're probably kind of familiar with these things, but what is actually happening behind everything there is that you're taking a transformer model. It has been fine-tuned for basically creating these embeddings, and you're feeding text into that and creating those embeddings, right? So exactly what you can see right here. That is what those sort of embedding approaches are doing. So yeah, if we go on to the next slide. So like kind of putting all those things together, right? If we're going to do RAG, we want to do it with semantic search because of these reasons, right? So we have the retrieval of highly relevant documents using natural language, right? Everything we do with LLMs is natural language, so that's super important. If you do it right, you can scale this to billions of records. So you're not necessarily limited by only like with the context window issue, right? You're not limited to how many records or how many documents you can search there. You can do data management, so you can be very in control of what you see in there. And yeah, you don't need to do context stuffing. So you are going to save money. You're not throwing in so many tokens. And at the same time, you are not sort of damaging the performance of your LLM. Okay, so yeah, next slide. So, I mean, Bill Gay will go into a lot more detail here, but I want to, at a very high level, look at what a RAG pipeline would look like. So as I mentioned, right, we have our query at the top there. It's what makes Llama 2 special. If we feed that directly into an LLM, Llama 2 is a new, sort of newish large language model. If we feed that directly into an LLM, most LLMs will have no idea what you're talking about because they haven't seen that before. They don't know what Llama 2 is. So that's why we use a RAG. We take Llama 2 or that query into an embedding model. So like ARDA 002, we create a query vector, send that across to Pinecone, and then we get like a set of documents or contexts. These are, they could be snippets from PDFs or whatever else. So we return those, we add those to our query before we put it into the LLM, and then we like give it all to our LLM, and our LLM will actually be able to use that information to give us a better response. Cool. Next slide. Yeah. So that's RAG. Actually, so at the within the last visual, there's kind of like the little Pinecone logo on the left. That is your, where we store everything, your vector database. The idea behind vector database is just a semantic search that you saw. So you put in your query vector, and we're just kind of returning those contexts or documents that I mentioned before. So next slide. So Pinecone is like a service, managed service that does that retrieval component for you. So the vector search part. So Pinecone's like it's purpose-built cloud native vector database that does vector search very well. And I remember before I started working in Pinecone a long time ago, I was doing freelance work, and one of my projects was actually like build a vector database. Although back then it wasn't like I didn't call it a vector database, and I don't think anyone else did either. And it was just like you expect it to be relatively simple, but it's an absolute nightmare. So there's just so many things that you have to handle, like keeping your data up to date, managing that data, refreshing your index. There's a million things. So one of the best things about Pinecone is just like managing that, right? So you sign up, and you don't have to spend like engineering months building your own. Also scales. Like there's no way whatever I built back then would have scaled to 10 billion records. And it has integrations with ML frameworks and LLMs like Haystack. So yeah, that is Pinecone. And I think, yes, I'll hand it over to Bilge.
Yeah, thank you for the presentation. I think you explained everything about RAG, and now we'll start talking about how to implement RAG in practice. And before we jump into that, I'd like to introduce Haystack and how we can use Haystack. Haystack is an open source framework built in Python for custom LLM applications. It provides tools that developers need to build state-of-the-art NLP systems. And it has two building blocks, pipelines and components. Components are the smallest units. They do one task, but they do it very well. And by connecting components to each other, we create pipelines. So this is like the high overview of what Haystack is. Oh. All right. So this is a RAG system in high level. So here we have a document store in the middle and two pipelines on the right and the left. So document stores in Haystack are basically vector databases like Pinecone. And the indexing pipeline is what we use to process our documents or split them before we put these documents into document store. And we also use the indexing pipelines to create embeddings, as James explained, like with the encoder models. And we store our documents with their embeddings in the document store. And the other pipeline is the query pipeline. This pipeline is where you usually query the whole system, where you interact with the whole system. And here you can use some of the language models from Hugging Face, OpenAI, or Cohere if you are using Haystack. Here I'll explain in practice how to create the whole RAG system using Pinecone and Haystack. And I explained first you need an indexing pipeline to put all of your documents or all of your sources to a document store. So for this example, I imagined using not like documents that we already have, but crawling them from the web. So for that, we need the crawler component that Haystack has. And we connect the scroller component with the preprocessor. So we get the documents from the web, we split them, maybe clean them. And with the embedding retriever here, we create embeddings for each document before we put them into the Pinecone document store. And this is how it looks like in the code. The first part is how you create the Pinecone document store. These informations that we used in the class are already given by Pinecone if you just create your index in Pinecone. And for the crawler, you just give a URL or a list of URLs. For this example, I just put the documentation of Pinecone so that we can create a system that can query the whole documentation of Pinecone. And we have a preprocessor component which is like here we define how we want our documents and maybe we want to split them by word or sentences, and we can also set this split length here. And as the last, it's the embedding retriever. It's the component that we use to create the embedding. So for this component, we define an embedding model. It can be a model from Hugging Face, or as James said, it can be from OpenAI, it can be a Cohere embedding model. So there are a lot of integrations in Haystack. And in here, we just connect these components and we create this pipeline. So when we run the pipeline, now every document will go through the components in the pipeline and will get indexed to the document store. So this part is done. The other part is the RAG pipeline. So RAG pipeline is quite small, shorter than the indexing pipeline. We only have two components here. The first one is the embedding retriever. It's again the same retriever that we use in the indexing pipeline. This one embeds the query, so it creates the embedding for the query, and then sends this query to Pinecone, and Pinecone calculates the similar documents, so it calculates the similarity and returns the relevant documents to our query. And then we'll send these documents and the query to the prompt node. The prompt node here is our connection to the LLMs. It can receive inputs from other components or from the user, such as query. It sends the prompt to the LLM and then returns the response as the answer. So this is how you would implement a RAG pipeline in practice. But let's see the code. Here is the prompt that we use for a pipeline like this. So this is a template, so it's not the final version. Here we have a sentence explaining what we want LLM to do. And then we have prompt variables. Then these variables will be they're in curly brackets. And these variables will be then filled with the retrieved documents from the embedding retriever and the query that the user sent us. And we put this prompt template to our prompt template component. And then here we pass that template to our prompt node. Again, it's the embedding retriever. Here it has the same embedding model, and we put these node components in our pipeline, and our RAG pipeline is finished. But this is not enough to have a conversational system. So we have a great generative QA pipeline, so we can ask our questions and get answers. But in order to make this a conversational system, we need a couple more steps. And the first step is the agent. So what is agent? Agent is a system that uses a large language model to perform complex tasks by processing information retrieved from external sources. So in pipelines, it was quite easy because there was only one knowledge source and the path was already defined. So it was like from embedding retriever to prompt node. So there's no other way to go. But for the agent, it's a bit different. So the agent itself needs to reason, create an action plan, and act according to this action plan to answer a query. And for that, it can use several tools. For example, this agent has 4 different tools that it can pick from. But how does it decide which tool to use, or like how to create this plan? So first, the agent gets a query. So then it thinks, okay, I have a query. So user wants me to do something. What do I do? So it's a thinking process, a thought. And then it chooses a tool to resolve this thought. It can be tool 1, tool 2, tool 3, so any of the tools that you provide to the agent, the most suitable one. And then it queries that tool. That tool, of course, can be a pipeline, can be a prompt node, can be any external API. I mean, you define it. And then it gets the output from the tool and observes, is that the correct answer? Is it the final answer or not? And according to the answer, it's either generates the answer or goes through the loop again and checks another tool to resolve that query. So let's talk about the features of an agent. Agent, in essence, a prompt node that connects to an LLM and has a very clever initial prompt. I'll talk about it in the next slide. I'll talk about the prompt in the next slide, so you'll see how fancy the prompt is. So agent has access to a variety of tools. So as I mentioned, it can have 1 tool or more, and you define the tools here. Oh yeah. It can be Haystack pipelines, the tool, data connectors, or the web itself. And each tool can be useful to achieve one specific task. For example, one tool can be a pipeline, a generative QA pipeline, and the other one can be a calculator. So, but it's better to just define a small tool so that it performs one task in the best way. And according to the tools it was provided with, the agent creates a plan to resolve complex queries and do so by invoking and orchestrating the tools that it has at its disposal. And as the last item, it can also have memory, and this memory can be the whole conversation or the summary, and I'll talk about that in the following slides. So, we'll create an agent using Haystack, and this is the diagram of the agent that we are going to create. For demonstration purposes, it will only have 1 tool, and the tool that we will provide to our agent is going to be the RAG pipeline that was connected to the Pinecone document store and that we created earlier. All right, so this is the agent prompt. If you remember, the RAG prompt, so Retrieval Augmented Generative Pipeline prompt, it's quite longer than that one because it's full of instructions and it kind of guides the LLM on what to do. So let's check the prompt and see the sections. So the first section of the prompt is about what we want from this agent. So we already know our tool and there's only 1 tool. So we can instruct our LLM saying that, okay, you are going to be interacting with this tool and this tool has an access to Pinecone documentation. Try to find the answer using that tool and make your answers based on the output of the tool only. So don't create anything from your training data. Try not to hallucinate, basically. And here again in the curly brackets, you see a prompt variable. And this part of the prompt will be filled with the tools that we are providing to the agent. And the rest of the prompt is about how to create an action plan. So here we want our agent to have a thought, and then we want our agent to pick a tool and decide what to input to our tool. And then we see the observation of the tool, and we again say our agent to like think about the output of the tool and decide if it's the final answer or not. And here also at the last part, we have the question. This will be filled with the user's query. And the last part is about the thinking process of the agent. So let's see how we can create this agent system with Haystack. We already created the RAG pipeline. So RAG pipeline will go to this tool as the pipeline, and we're gonna name it. Here we name it with Pinecone _ dogs _ search. So you can pick any name, it doesn't really matter here, but try to find a very nice description, because this description will be then used by your agents to decide if it's going to choose this tool or not. And then we create a prompt node here specifically for this agent. As if you remember, we said like agents are basically LLMs, but these LLMs are prompted in a way that they can create an action plan. That's why we create this prompt node, again, with the model that we want, and we give our information like here. Okay, so basically what we need to create the agent is passing the prompt node, passing the prompt, that fancy, clever prompt, and the tool that we have. In this example, it was the RAG pipeline. Okay, so what happens if we query the agent? If we say, and remember, it was connected to Pinecone documentation, so we can ask questions about Pinecone documentation. So we ask this agent, what are the features of GCP starter? So here in the first line, the agent says like, okay, I should use Pinecone doc search tool to find the information. And it picks the tool, it picks the tool input, it observes the output in yellow, and it also has the thought. So it decides whether it's the final answer, and yet it says like, okay, it's the final answer. So yeah, it returns an answer that it retrieved from the tool. But what if we ask a follow-up question here? So can you elaborate on the second item? Here, our agent is not capable of answering this question because it doesn't know what second item refers to. However, if this was a conversational system or this was a human, it will say like, okay, it should be the second item that I answered. So I should understand that and answer this question accordingly. But yeah, our agent right now is not capable of referring what second item is here. And to solve that issue, what we can do is to add memory to our agent. Basically, everything is the same, but we are adding memory. So to add memory, we need to make some changes, and I'm going to go through them in the next slide. So first, in the prompt, the rest of the prompt can stay the same, but we need an extra line. So we need to inform our LLM about the previous conversation. So we need another prompt variable in our prompt so that it will be then filled with the conversation that we had with the AI agent. And the second thing is adding memory. So there are two types of memory in Haystack. You can either summarize the whole conversation, or you can just put the conversation directly to the prompt. You can choose to, here I chose to summary the memory, and also to summarize the memory, I used another model, which is a summarization model, which is a very good model at summarizing conversations actually, and it's an open source one. And after creating our memory, we just in addition to the tools and the prompt node and the prompt template, we just add this memory, and our conversational agent is ready. And let's see how it reacts now. Okay, so we ask the same question again, and the answer is the same. So because like for this one, it didn't really need a memory. But if we ask a follow-up question, such as like, what are its limitations, referring the GCP starter, it can now refer that we are talking about GCP starter and check the tool input here. It replaces it with GCP starter and query the tool with the proper query. And since now our tool can understand what this means, and it again goes through the Pinecone documentation, generates an output, and our agent then, by observing the output of the tool, it can create a final answer. So this is that was how you would create a conversational system with RAG and memory. And let's see the whole notebook together, and maybe like try another query. Oh, all right. So we need to do, I have prepared this one, but we need to do everything from scratch now. So, oh no, okay, it's connected, great. So here, what we do here is like installing from Haystack with Pinecone, inference, because this is the optional dependency that we need for the embedding model, and the crawler, because we're gonna crawl Pinecone documentation. Here we enter our keys for OpenAI and Pinecone, and here we create the document store. I already shared the code for this with you, and we don't need to index documents already Pinecone because I've done that. And here we see that, okay, we have some documents in our document store, so everything is fine from indexing side. So this is the RAG pipeline. It has its own prompt, so it can generate an answer depending on the documents it retrieved. And here we create the conversational agent. We create the tool, we create the prompt node, we create the memory, and the prompt is here, that fancy prompt. And yeah, now we can create, now we can try the questions. We can try something else. We can say like, okay, can an organization member create projects in Pinecone? I've already run this, so I won't rerun it, but I'll share the link with you. And I've already put the QR code in the presentation, so you can test it out yourself. Here again, it picks a tool, the tool that we provided, it queries the tool, and then it generates an answer. Yes, organization members in Pinecone can create projects. So that's fine, that's great. And that's correct, by the way. I think James can confirm me. And the other question goes, can they manage billing? So if we would be having this conversation with James, when I say like, can they manage billing, he would understand that I refer to organization members, right? So now we'll see if our agent is clever in that sense. And yes, it is clever. It says like, since the question is about managing billing, I can use the tool and check out the tool input. Can organization members manage billing in Pinecone? So it could refer that when I say they, I refer to organization members. And it says like, no, they cannot. Only organization members have the ability to manage billings in Pinecone. So that was about it. And this is how you would create a system using Haystack and Pinecone. And yeah, I think we can answer some of the questions if